Hello, this is Dr. Gaetano Lotrecchiano from George Washington University, and I have the pleasure of offering my thoughts on complexity competencies in transdisciplinary research teams. What we hope to achieve in this short presentation today is a discussion about cross-disciplinarity and complex adaptive systems, what knowledge producing transdisciplinary knowledge producing teams are, the complexity challenges for these types of teams, and with a focus on competency. A reflective prompt that might be good to have in the background of today's talk is how might we advance the notion of complexity science and transdisciplinary knowledge producing teams, emphasizing the skills required to work within those types of teams in this modality. A little bit about what a complex adaptive system is. The theory around complex adaptive systems comes from complexity science, and what it outlines is that systems, i.e., teams and organizations, are adaptive in that the influences that come from interactions of agents and their future interactions affect system-wide patterns. And this is a very iterative process. So, in other words, as individuals interact with each other, they're influencing future interactions which affect the system-wide patterns. And this is an iterative feedback loop, so that people in teams are constantly creating what the behaviors, cognition, attitudes are about the team, and at the same time, the team is evolving as a system. You'll note that in places in my talk, I have a QR code. You can use that to go to original source material and or papers that have been written that are all open access. So I hope you take advantage of that opportunity. So this idea that teams and systems are not linear has actually changed the way we've looked at things, even within NIH. So many of you are going to be familiar with the clinical translational research spectrum, which used to be described um, uh, similarly to the image on the left, where between basic science and the translation and implementation to populations was sort of seen as a linear process with chasms in between them where there were opportunities to shape and affect the different types of research that go into large-scale initiatives. Since its inception, NCATS has changed the model. It may seem like a simple change, but actually, as you see in the image on the right, this model is more iterative. It has more feedback loops. So the clinical research informs public health, which informs preclinical research, et cetera. This is a good example of an adaptive system where the different modalities within translational research are considered to feed back into each other. So you can think of this more as a complex presentation of the efforts associated with translational science. So let me give you just sort of a very quick primer on the language we tend to use in complex adaptive systems. So this is these are definitions of what complex adaptive systems are. They're places for information exchange where interaction of multiple elements come in contact with each other. Either those be individuals, or they are organizations or external factors that require the team to be agile and to be able to respond to different types of information that are being shared within a team. Complex adaptive systems are nonlinear, and the example I just gave you before in the previous slide with the two interpretations of what translational science is, it's not one dominant framework, but it's like that second picture I showed you where there are multiple entities that are feeding back into the system and in fact renewing the system as it continually unfolds. These are called feedback loops, and they may enhance, stimulate, um, detract, or inhibit, but both kinds are really necessary, because if it's constantly an environment where it's everything is stimulating, and or if you want to call it positive, we don't get the information exchange that actually challenges or makes us rethink how adaptive systems need to adapt. And my fourth point here, feedback loops serve as entropy. Entropy, if you're unfamiliar with the word, is energy, basically. It's not necessarily good, it's not necessarily bad, it's just energy. So this is energy that will influence the system. So if it's, to the third point, considered positive or negative, really both aren't, it's not a binary situation. It's rather that systems are stimulated by the energy that this sort of feedback into the system actually creates. Change is a continual steady state when we talk about adaptability. And that is something that we need to embrace, because without embracing change as a constant state, we basically aren't able to be adaptive within a team. So the history of complex adaptive systems, is constantly drawing on the fact that there's really no one entity or event or one actor in the system that controls the system. So organizational challenges or supports different individuals' viewpoints on matters having to do with the science, or maybe even events like world events like COVID, for instance, are all part of the adaptive process of how systems, and I use systems here, of course, to talk about teams, which are a system. All activities contribute to the growing knowledge about the system. So teams often have changes. They often have people that are more important, maybe, to or closer to the problem that's trying to be solved, and others who may be less central to the problem that's trying to be solved. But all that contributes to the ongoing development of a team, a system. And lastly, interaction between system components, people, social phenomena, different knowledge is foundational to how we understand adaptivity in systems. So this is just really a primer to sort of get you into thinking about what the characteristics of complex systems are. Now, you may have heard of the science of team science and team science. They're slightly different things, but the science of team science is a field where we focus on collaborative efforts that that serve solving scientific challenges. It leverages the strength of professionals trained in different fields. So we often have the challenge of ensuring that different fields and different people and people who either are dealing with the problem or studying the problem are often coming in contact with each other. So oftentimes, team science is helpful in understanding how complex social problems are dealt with, understanding that there are multiple causes for the problems themselves, therefore, it requires multiple inputs. And the promoting of teams and the study of its effectiveness is at the core. So, the science of team science is the actual studying of teams so that we can learn what works in teams, what behaviors, attitudes, how we need to think actually will contribute to better science that's tackling more complex um, uh, problems, or at least attempting to. So there are two resources that are free. They are federal publications. One is the Enhancing Effectiveness of Team Science. The other is the Collaboration Team Science Field Guide. If you are so inclined, you can click on the QR codes and you'll be brought directly to those resources. So within teamwork, we always have to differentiate between the tasks that go into reaching your goals, and these could be, multiple tasks that may involve collecting data, that may involve administration, it may involve analysis, et cetera, et cetera. This is what we call the task work, what needs to be done to actually meet our goals. And I use this cartoon of Nemo and Dora to show that we often just think that if we just keep on working, we are going to meet the goals of our team and solve those complex problems. The challenge is it's not just the tasks that contribute to the success of teams. So this is where team science offers a different sort of approach to team work that's beyond just the task work. So it's the attitudes, the behaviors, the cognition that is necessary so that individuals can be successful in being able to create mental models which are shared, even though members of a team might have very different contributions. It's looking at what type of attitudes are needed, what type of behaviors are going to ensure that there are good and positive interactions between people, and then what knowledge is base knowledge or even complex knowledge is necessary from everyone on the team, no matter what your role or responsibility is. And it's akin to being sort of on the same page versus not being on the same page, if you want to think about it that way. So you see this image of the Sex and the City girls who are really all enjoying the same thing. They are clearly focused on something that they're doing. And we have Bernie Sanders, this very famous picture from the last the inauguration of Donald Trump, where he just sort of sat there. He really wasn't mentally, attitudinally, behaviorally, or even maybe even cognitively on the same page at that time. So when you splice these two images together, you see that if this were a team, we might actually have some attitudinal, behavioral, or cognitive work to do so that everyone can participate in a way that is ultimately equal and also contributing to the same goals. So a little bit about cross-disciplinarity. Uh, we know what unidisciplinarity is. It's basically built on a tradition of science that someone may do. It tends to have a singular history. It may be linear in perspective. It tends to be a closed system where if you're not trained the same way or you don't have that knowledge base, you can't really get into it. So if you are possibly a social scientist working with mathematicians, it very may be possible that it's really hard to permeate what the mathematicians are doing because the social scientist may have no training. So the mathematician is sort of like a bubble, as you can see here. And these disciplines typically do not interact with each other. They sort of just hang out there uh, um, in space, sort of doing their own thing without interactions at all. I've created something called a complex adaptive system odometer. And in this case, yeah, there we go. In this case, we're looking at sort of a painless interaction because we can just continue to do what we do and not really have to work on the skills necessary to interact with others. In a multidisciplinary system where there is more interaction between different disciplines, different types of people, as you can see on the figure on the left, it leans more towards shared histories, shared knowledge. The system is more permeable, and they have similar realities, and yet there's really no adaptation, really. So imagine going to a lab meeting or going to a research meeting, and 10 people are sitting around a table talking about the research project, and we go around the room one by one and get everyone's input from their corner, their disciplinary corner on the project. But we really don't change anything. We don't adapt. So, the possibly a statistician does not change the way that a social worker is looking at what they do, and vice versa. So I think of it more like people sitting around a table that were not purposely seated next to each other, but rather just go around the table, all putting into the middle of the table what it is they bring to a project. And on our meter here, that's a little more discomforting because it requires us to represent the field that we may be the field that was the reason we were asked to participate in a scientific effort, but it really doesn't have inherently the goal of changing the way we look at our individual disciplines. When we look at interdisciplinarity, we're moving a little further into the intersection points where things start to not just overlap, but make connections in a way that otherwise would not be possible in a multidisciplinary environment. These are intersecting and interactive systems. Like we're starting to understand better how, say, for instance, a biologist is able to work with a neurologist, possibly, and start to see how those two elements interact with a particular problem. The interactions are more blended, they're conversations, and they have a more common reality. And now we're starting to see more adaptation. So in our meter, you might consider this being a more intense interaction. It does start to show signs of adaptation, which is important. Now, transdisciplinarity, which is the highest form, I guess, of why we do cross-disciplinary work, is much different. Not only are we sensing the connectivity between different overlapping disciplines, we're also making connections between how those overlaps can contribute to something truly novel. So Here we start to see more holistic histories and traditions. So we see this a lot when we, say we're doing neurobiology. Okay, that's an example of an interdisciplinary arrangement. But once we start to take neurobiology and put it together with other interactive points, like, for instance, affect, or something that's much less uh, what neurobiologists would study, we start to come up with opportunities to amalgamate. These are now open systems; they're no longer closed. We aren't necessarily hanging on to our own disciplinary tradition. We are starting to understand how these intersection points have meaning when you start to compare them with each other. Um, it's the type of work that requires reciprocal interdependence, which means there's no way possible the problem could be solved without reciprocity to others on the team and an interdependence instead of just a dependence. There multiple realities may emerge from these sorts of arrangements, and it's truly transformative. So, transdisciplinary work can generate and will generate and is expected to generate totally novel ways of understanding a problem and providing its solutions. It's sometimes unmanageable because people don't have the confidence or the skill sets to actually engage in this sort of work, which is why we need to consider what our expectations are of transdisciplinary knowledge producing teams. So, the types of teams we're referring to here are groups of scientific collaborators. They are expectations that their work is going to be knowledge generating in some way, or possibly creating knowledge. There are task oriented goals. There's a lot of shared equipment and technologies, and they develop professional and interpersonal relationships. This goes way beyond just participating in a team and just representing yourself or representing the discipline that you are an expert in. There are team processes that need to be worked on to ensure that people have the right um, uh, attitude, behavior, and cognition to enter into this sort of environment for both learning and knowledge generation. And typically, transdisciplinary knowledge producing teams are a lot of different types of skilled um, individuals. Some are used to working more autonomously, and others are possibly used to working more in teams. But when they come together, that needs to be worked out. It needs to be understood. So, what I'm saying is, time needs to be given to how a team is going to sustain itself, not just through the knowledge that individuals share with each other, but more deeply, how are we going to ensure that we can be adaptive enough to sustain the type of outputs that transdisciplinary teams are expected um, to reach. So when we look at competencies for transdisciplinary knowledge producing teams, there's really two categories that I break this down into. Structural, by the image on the left, which is a bunch of girders that are holding something together, and the other is interactions between individuals. So, what are structural system complexities, and what is the competency development that's needed? So, from what I've explained to you about knowledge producing teams, transdisciplinary knowledge producing teams, is that their structural system complexities are those that involve complex problem solving. stakeholder involvement, methodological pluralism, and practice. These are the structural elements. Imagine them being the spine of what it is transdisciplinary teams are required to do, and the different types of skill sets that are necessary. So, for instance, let's just look at a couple of them. Complex problem solving. The skill to understand that goal alignment is really in conversation with changing world, where we need to understand our initial goals may not be our ultimate goals. Co-developing shared mental models within a team. So it's not one group's mental model that everyone else has to appeal to, but rather the group co-develops mental models that ensure they're on the same page. Stakeholder involvement is very much ensuring that people are receptive to having people on teams that may not, for instance, have letters after their names, like many of us do, but are the people that are most affected by the problem. So, I usually say to my students, if you're working on a project in cancer, the expert in cancer is the person living the experience of cancer. And those sorts of stakeholders involved in transdisciplinary teamwork are really going to bring the opportunity for a transformation into the way that we look at problems, fundamentally. And methodological pluralism is this need to be able to boundary span and not just boundary form. It's that pluralism in transdisciplinary work is a normative reality, meaning that there's often going to be a need to use different types of methods from different methodological lenses, and everyone may not be equally trained or receptive to that even, but this is normative in the type of knowledge creation that is going to be truly transformative. Lastly on this page is this idea of praxis, and that is bringing theory into the practical context of both doing research and understanding the implications of it. Now, the challenges associated with this are often there can be perceived inequities, where we believe that one methodological design is superior to another, for instance, or one of the fields of study is actually more important than everyone else. It may even be a hierarchical thing. So that can lead to an unbalanced problem ownership. So it's the problem solving agents are 3 people on the team, and the knowledge workers are 7 people on the team. So it can seem like there's an imbalance in who owns the problem. And this can be dangerous because then what we're doing, in fact, is creating structural complexities rather than overcoming them. There's a variability in communication types between different types of team members, and it's important that you're intentional about how you're going to get through those barriers. Sometimes it requires developing new language. Sometimes it's just a skill of being able to be comfortable with multiple languages that say the same thing. We find that a lot in team science, which is an interdiscipline that is made of contributions from management, leadership, the humanities, cognitive psychology, et cetera, et cetera. And these fields and disciplines talk about things differently. So there's this need to possess the competence to be able to live with that and to be able to openly work on it as a team to ensure that doesn't become a problem. So let's move now to the interactive complexities associated with transdisciplinary teaming. These are core interactive system elements like open system capacity, the idea that the team you may be working on is an open system, not a closed system. It's not, it's receptive to multiple inputs coming into it. There are different levels of reality within any project or any research endeavor, because we often don't look at problems in the same way. So, for instance, though a physicist and a cardiologist could explain how the heart works, neither are wrong, but those are different levels of reality, where a cardiologist is looking at it as a part of the body, an organism, etc. Where a physicist is looking at it as a displacement of gravity, propulsion, that sort of thing. Neither of them wrong, but they are different levels of reality, and that is normative to transdisciplinary work. Collaborative construction and reconstruction. Sometimes you need to deconstruct the way you have put together a team to reconstruct it in a way that embraces the core elements of what it means to be an adaptive system. So, for instance, recasting the level of openness that's necessary for collaborative and knowledge arrangements in teams, and direct contact with those affected by problems attempting to be solved, like really making more of an effort to ensure that the competencies of the team include this ability to sort of deal with the nebulous instead of looking for a concrete way to interact. And really, all of this is prefaced to what I've said already about the idea that transdisciplinary teams require complex adaptivity to meet the goals of what we expect from transdisciplinary teams. The challenges here are, of course, and very simply, um, um, differences in foundational training among team members, their diversity and changing career paths, their perceived insufficient legitimacy of a team to solve a problem. That is often a case we find that, it would be better if, you know, the neuroscience team grapples with this instead of including the biology team or the behavioral team, for instance, and often find that there are even conflicting epistemologies and ontologies that are really at the core of why different team members and teams look at problems differently. And then there are this challenge of different levels of transdisciplinary orientation. Let's face it, if a team is brought together, especially in an environment where we have, senior members of whatever it is, an organization or a university, junior members, but then you also have students, and we have people from the community that never studied. They have no idea what an epistemology is. These are different levels of orientation that need to be directly addressed, because this can be a challenge to really being able to be interactive enough in a team system for you to reach the goals and expectations of transdisciplinary work. So I started off with this reflective prompt, and I just want to say it again, because this may come up in panel discussion when we have the opportunity to do that. How might we advance the notion of complexity science in interdisciplinary knowledge-producing teams, emphasizing the skills required to work within a transdisciplinary modality. This is really what I hope. I've been able to seed you with some ideas about how you might construct, reconstruct, develop, your teams, so that in fact, we can be sure that we're heading to the highest level of knowledge integration and dissemination that transdisciplinary work requires. I thank you very much. I always appreciate hearing from people who have heard my talk. Please feel free to contact me by email or by phone. And again, I want to thank the organizers for allowing me to participate in this gathering. Thank you very much.